Here's my contactor economizer circuit. It's basically goes through these low side MOSFETs. The high side of the contactor goes through this filter system, and this actually it's this enabled MOSFET. It has to be turned on. This white jumper actually turns on. It's just going from 3.3 volt to that pin on or the old MCU. That enables the 12 volt rail for which is always on just for the contactor. And then this pin, which is right now we got the black one, which is for one of the contactors, the negative or positive, is connected to pin 12 on here, which when you push this button, it toggles the contactor duty cycle. There's the economizer at the bottom, there's a 25%. That's what I have it set to arbitrarily. And 25% is equals 6 watts for the whole BMS draw right now. If I turn it off, it's the 0.06 is the, 0.7 watts is without. And there it goes. It goes for 100 milliseconds to full 100% duty cycle, but the thing is filtered, and I'd have to put a scope on it to really know what the max current draw is, but I think it's acceptable. So there you go. That was pretty easy. It's really, this thing, all the work is done for us. Here's the ones for the high voltage the HVC, they call it. The charge port is those two pins right in front of my finger there. Those go to this buffer. It's basically just a buffer IC that goes then to the MOSFETs. It's like acting as a gate driver, but. And then that IC right there does the pack main positive and negative ones. It also, actually the buffers, I traced the signal for these MOSFETs that enable the rails for those contactors, and they actually go through some other channels in the buffer, and then, like I said, one of them goes to here. The one for the high voltage, the charge port HVC contactors was already enabled, so I don't know if it goes to it has just its own pull-up or something. But there you go. I'm pretty excited about getting this thing to function without any of these proprietary firmwares.